Hello everyone, welcome to Ekeeda platform, and this is Ravindra here, your electrical faculty. The subject is HVDC, that is high voltage direct current transmission system. Chapter is introduction of HVDC transmission system, and the topic which I am taking here is comparison of HV and DC system, your AC system, on the basis of technical performance. Now look at here. The first point I have already discussed, that is on the basis of economical factors. In the same way, we will talk about the technical performance. Now, if I talk about the DC system, okay, DC transmission system, then you come to know that as per the AC system, it has more advantages. Okay, now look, if I consider a DC transmission, if I consider a transmission, DC transmission. If I consider a DC transmission, then it is having some positive features, some positive features which are actually lacking in AC system. In AC system. Okay, guys. If you talk about the DC system and if you talk about the AC system, so the DC transmission is having the more advantages and it has having the more positive features as per the technical performance. Okay, so what are the advantages? Then you can ask, what are the advantages? First, it is having the fast controllability. It is having the fast controllability for over power transmitted. If the power is transmitted more than the expected value, then it is having the fast controllability, so that due to overpowering, no equipments should be damaged. Okay, now the second point you can consider here, it is having the ability to enhance the transients in the system, transients in transmission system. Okay, the next point, the third point is it is having the fast control. If once again, if there is a fault in the system, to avoid the DC breakers in the DC links. Okay, these are the some advantages. One is your fast controllability, another is your ability to enhance the transients, and another is fast control over the fault currents in the system. Whenever the fault is occurring in the system, if there is a transmission line, so there may be a chances of faults from generating to the load side at any point. So it is having, if we are using the DC transmission system, then it is having the fast control over the faults. Okay, now look at here. The DC transmission can overcome some other problems. If we talk about, if there in power system or in the transmission system, there are many problems or many faults conditions, or you can say the low voltage and the high voltage problem, overcurrent and low current problem. Okay, these compensations should be in the proper way. So in the DC transmission, that can overcome other problems in as compared to AC system. that is better to write. Okay, so what are that? Now I'm talking about the first one, that is stability limit. Stability limit. One is the stability limit. So now look at here. If you talk about the stability limit, the fundamental stability between the DC transmission and the AC transmission. Okay, if I talk about the AC transmission, if I talk about the AC transmission system or AC transmission lines, then voltages at both ends, let us suppose this is one sending end and this is the receiving end. So this is sending end and this is receiving end. So from sending end to receiving end, we are having the voltages as Vs delta 1 and Vs angle delta 2. So this transmission is actually depending on the phase difference between the sending end voltage and the receiving end voltage. So I can write here, this transmission is actually depending on, or you can write the power transmission is actually depending on the voltages and the phase difference of the voltages at both ends. It means at the sending and the receiving ends, voltages at both ends. Okay, I hope you have understood up to this point. Now look at here. Now I have talked about the sending end and the receiving end voltage. If I talk about the maximum power, so it is actually limited by in the AC transmission system. I'm talking about the AC transmission system. This is all about the AC transmission system. Then maximum power is actually limited by the steady state limit and your transient state limit. Okay, now the third point, the power carrying capability. Power carrying capability is actually depending on, I can write depending on. Okay, so power carrying capability is actually depending on the distance, so I can dictate it with one diagram. Now look at here, this is the y-axis, this is your x-axis. Now this y-axis actually representing the power, this x-axis is actually representing your distance. Okay, if I draw the curve of AC transmission system, then at the initial from the generating side, it is having the curve like this, but after some point, after some distance, it will go like this. So this is about AC. But if I talk about the DC transmission, look at here, this is the DC one. It is constant all over the distance. So throughout the distance it is constant, but if I talk about the AC system, it is going like this. It is decreasing. It is, you can say, decreasing after some point. Okay, so up to this point, look at here, up to this point I can write both an AC and the DC system, the power carrying capability is exact, or you can say is comparable. But after some distance, after some point or some distance, the power carrying capability of the DC is better as compared to the AC. So I can write the power carrying capability is better in DC transmission transmission system as compared to AC transmission. Okay guys, this is the basic graph. I hope you have understood the stability limit. Now I'm talking about the second point, which is actually voltage profile. voltage profile voltage profile. Okay guys, now what is the voltage profile? According to the distance, with respect to the distance from sending to the receiving end, the voltage value of AC and DC will vary. Okay, and that is actually depicted by one graph. Okay, now look at here. So what is the voltage profile? Now look at this. If I talk about the AC transmission system, there are the many equipments so that we can control the voltage profiles, such as the your compensation techniques are used. Okay, so if I talk about the AC transmission system, there are many techniques in the AC lines, such as your line charging. One second, line charging and reactive. Not reactive, you can say that inductive is better to write here. Inductive voltage drop. Okay, now look at here. In the power system, there are huge amount of capacitors and inductors, and which are actually, this capacitor actually causing the line charging, and this inductor, okay, is causing the inductive voltage drop. So these are the some effects are causing in the AC lines. Okay, now if I talk about the voltage profile, if I talk about the voltage profile of the AC transmission system, it is actually varying accordance with it is varying in accordance with line loading. Line loading, you can say, the load side. At the load side, there are the many equipments and the many factories are running, so the demand of the consumers are increasing or decreasing. According to that, the line loading is varying. So according to the line loading, the voltage profile is drawn. So I'm drawing in the next page. Look at here. So in the next page, look at here. One second. This is our baseline. Okay, and this is the curve here. Okay, I can write here, this is the sending end voltage, or I can write the sending end point. This is receiving. Okay, and this is the constant profile value. Now at this point I can write the Vs is equal to V, and this point I can write to VR, that is VR receiving end voltage is equal to V. Okay, now look at here, I'm taking line. Look at here, this point at this point, or you can consider at another point here. Okay, now these are some values here. Now look at here, you can come to know that this is actually the total length from here to here. This is L, this is represented by L, and it is actually length of transmission line. This voltage Vs is actually the sending end voltage, this Vr is actually the receiving end voltage, this upper curve and this lower curve, and this is another one, middle one, which is actually the constant value. I can write here this point, at this point from sending to receiving, and this curve actually representing, I'm writing here, that is P is less than Pn, and here I can write here P is greater than Pn. But at this point, this is, I have already talked about that P is actually Pn. If I talk about at some point value or some distance or some random distance from this point, from sending end to the receiving end, we are considering the length is equal to L. In between them, I am considering one distance that is from here to here, that is X. At X point, I am talking here that the voltage is from here to here is Vx. Okay, from here to here it is Vs, from here to here it is Vr. So it is actually decreasing. You can look from this graph. Okay, now I'll talk about some other points. Okay, now if I talk about the maintenance, of constant voltages at two nodes, or you can say two ends, then reactive power should be controlled. Okay guys, if I talk about the maintenance of the constant voltage, at the two ends, okay, then the reactive power is main consideration, and which should be controlled. If you look at the DC transmission system, in AC transmission system, if I talk about the power in the AC transmission system, if I talk about the power, okay, then it is actually S is equal to P plus JQ, and this Q is actually reactive power. Okay guys, and this P is actually real power, Okay, now look at this. At this point, this P is actually a real power. Now, the reactive power requirement actually increases as your length increases. This is the main point you have to know. Okay, now another important point I can add here, which is that to avoid the problem of steady state charging current. Okay, if I talk about the problems which are caused by the steady state charging current in the AC lines, then break even distance. We have already talked about the break-even distance in the economical factors in the previous lecture. So break-even distance should be approximately 40 km. I hope up to this point you have understood properly, and thank you.